Alright, so in this video we're going to be going over some calculator multiple choice questions on a practice AP exam that I have written. This is not an official one, it's just one that I've made up. So we're going to go through it, and we already went through section 1 part A in the last video, which was this non-calculator multiple choice, and now we're going to go over the calculator multiple choice, which is section 1 part B. And if we look at the timing here, we have 24 minutes for 8 questions. So it's a little bit more time per question than the first section, and that's likely because the calculator adds some extra work that you have to do to get the answer. Okay, so section 1 part B, 3 minutes per question, and the graphing calculator is required for some questions on this part of the exam. It's not like the SAT where you could technically do everything without it. It would be really hard to do some of these questions without a calculator. Okay, so like I said before, I'd recommend that you print it out, do it yourself, or at least do it with me. Pause before I solve each question and try to do it yourself. But with those warnings out of the way, let's get started with question number 1, or 15, as it were. Let f of x equals x squared plus 5x to the 4th minus e to the 2x, and let R be the region in the first quadrant bounded by f of x on the x-axis. Find the volume of the solid generated when R is rotated about the x-axis. Okay, I think I'm going to go with teal today. I'm in teal mood. So how do we do this question? Well, the first thing I would do is I'm going to graph this. And we're just looking at the first quadrant, right? That's when x and y are both positive. So we look at we see this region like this. And this is the region that we're going to rotate about the x-axis. Right, this is the x-axis. And so what I want to do now is I want to find these intersection points. And in the calculator, if I find the zeros of this function, which are where it intersects the x-axis, I find that these two zeros are 1.143 and 3.038. Okay, now the next thing I need to do is I need to rotate about the x-axis. So I need to think about, okay, what formula am I going to use? And the formula in this situation is going to be pi times the integral from a to b of r squared dx. Because there's only one curve, so I'm only going to be using one r. And that r is going to be the distance from the x-axis to the curve. And as you can see here, that's going to be x squared plus 5x squared minus e to the 2x, because that's just the y value, that's the height of this thing here. Okay, so I know this is my r, and I have my a and b. This is my a, this is my b, and so I'm ready to plug everything into the expression and solve for it and get the answer and move on. So I'm integrating from 1.143 to 3.038 and r squared, so it's going to be x squared plus 5x to the 4th minus e to the 2x whole squared dx. And if I evaluate this in my calculator, I get 6,668.218, which gives the answer of D. 16. If dy dx is proportional to 2y, and y of 0 equals 4, and y of 1 equals 23, for what value of x does y of x equal 2,500? Okay, so the first thing to realize is that this 2y, this 2 is completely irrelevant. Because when I say dy is proportional to y, that just means that if dy dx increases by some amount, then y is going to also increase that by that amount. So if dy dx doubles, y is going to double. That 2 really doesn't really mean anything in this situation. So what I can say is I have it proportional to y. So now I can use my equation for this kind of situation, which is y equals y naught e to the kx, where y and x are my variables, k and y naught are constants. Y naught is my value at 0, y of 0, and k is just a generic constant. And then I'm actually given here that y of 0 equals 4, so I can replace y naught with 4. For k, I'm going to have to use this other point where y of 1 equals 23, so I'll plug in 23 into here and 1 into here, so 23 equals 4 e to the k. And if I solve this for k, I'll get that k equals the natural log of 23 over 4. You could keep it as it is. You can store it as a number in your calculator, whatever you prefer. You can even use an estimate of this because this is a multiple choice question. But either way, I'm going to keep it just as natural log of 23 over 4. And we can plug this k value back into here. So y equals 4 e to the ln 23 over 4x. So now I can solve my question for what value of x does y of x equal 2500? So I'll set this equal to 2500. So 4 e to the ln 23/4x equals 2500. And the way to solve this is, the best way is by graphing. You put this in y1, you put this in y2. You could solve it normally if you want, but I'm lazy, I'll graph it. Thank you very much. Put this in y1, y2, find the intersection point, and that's the x value, right? And so when you do this and you get the x value, you get that x equals 3.680, and that's option D. 17. A person releases a balloon 2 feet away from them, which floats up at 5 meters per second. As the balloon rises, the person tilts their head up to look at it, forming an angle theta with the horizontal. After 2 seconds, what is d theta dt, the rate of change of theta with respect to time in degrees per second? Okay, so what I'm going to do here is I'm going to, first of all, admire my artwork, because I think it is a beautiful piece of art. You can really tell my artistic, my prowess here. So now after we've admired that sufficiently, we're going to go ahead and draw an image. And so this is a right triangle. Here's my angle theta. And I'm given that the balloon is 2 feet away from them. So this distance is 2, right? This is the person, this is the balloon. And then the distance is 2. And it's floating up at 5 meters per second, right? And I'm 2 seconds into this journey. So in 2 seconds, the balloon will have traveled 5 times 2, which is 10 meters up. So this distance is 10. By the way, this whole drawing is at t equals 2, right? So I can find out theta because I know 2 of the sides. I know that tangent of theta is equal to y over x. In this case, y is 10, x is 2, so this is equal to 5. Therefore, theta is equal to the arctangent of 5, which is approximately 78.69 degrees. Okay, now I'm going to make a list of all my known values and whatever I'm looking for. This may seem unnecessary, but it'll save a lot of time when we solve the problem. Well, it'll stop us from needing to search for stuff over and over. Okay, so we know that x equals 2. We know that y equals 10. By the way, again, all of this is at t equals 2. Okay, we know that the rate of change of x with respect to t is 0, because this horizontal distance between me and the balloon, between the person and the balloon, is always constant. No matter how high the balloon goes, this distance is always going to be 2. I know that dy dt, which is the rate of change of the height, how quickly it's going up, that's 5 meters per second. So dy dt is 5. I know that theta equals 78.69. And then what am I looking for? Well, I'm looking for d theta dt. Okay, now that I have that, I'll take my equation, which I am working with, which is tangent of theta equals y over x. And then I'm going to take the derivative of it with respect to time, because I'm looking at how quickly these things are changing with respect to time. So if I take the derivative of tangent with respect to time, I'll get secant squared theta. And remember, for these, we always add a d whatever dt. So in this case, it's the d theta dt. And then equals, so to take the derivative of this side, we have a quotient, right? So I'm going to use the quotient rule. So I'll have x times the derivative of y, which is dy dt, minus y times the derivative of x, which is dx dt, over x squared, the bottom squared, right? Now I can solve this for d theta dt, because that's what I'm looking for. And that's just going to be taking the secant squared theta and bringing it down. This is going to be x dy dt minus y dx dt over x squared. Okay, and what this is this is going to be, oops, sorry, I forgot the secant squared theta. I apologize. Secant squared theta. And what this is I can plug in all my numbers from up here. So x is 2, dy dt is 5. This is going to be 2 times 5, which is 10. And then minus y, which is 10, times dx dt, which is 0. So I'm going to be subtracting 0. And then I'm dividing by x squared, which is 4, times secant squared theta. Well, I know that theta is 78.69. This is going to be secant squared of 78.69. Okay. But remember, cosine is 1 over secant, right? So I can take this and move it up and make it cosine, because at least in my calculator, I don't have a secant button, but I do have a cosine button. So this is 10 cosine squared of 78.69 over 4, for the degree of sine, I guess. And if you evaluate this in your calculator, you are going to get 0.0962, and that is the value of d theta dt. And if we go here, there it is, option A. Question number 18. The acceleration is given by a of t is sine theta sine t cosine t, where t is between 0 and pi. If the velocity of the particle at time t equals to pi over 4 equals 0, at what times is the particle speeding up? Alright, so whenever we're looking at speed, we're looking at both velocity and acceleration, right? So whenever you see the word speed, always find both velocity and acceleration. That's key. So I have my acceleration, and to get velocity, I have to think about, okay, what's the relationship between acceleration and velocity? Well, I know that the derivative of velocity is acceleration, so since I'm given acceleration, to find velocity from that, I have to take the integral of the acceleration. So I'm going to be integrating sine of t cosine of t dt, and this is going to give me my velocity. Okay? So to do this, it's going to be pretty simple integration. It's just going to be a u substitution where u is equal to sine t. That's going to be du equals cosine of t dt. So this just becomes the integral of u du, which is u squared over 2 plus c, which is sine squared of t over 2 plus c, because u is equal to sine of t, so I just took that and I plugged it back in for u here. So I have this, and now what I can do is I can say, okay, this is my velocity function, right? So I know that at the velocity at t equals 4 equals 0. So I'll say that v of pi equals 4 equals 0, so I'll plug in pi equals 4 into here and set it equal to 0. That'll allow me to solve for c. So sine squared of pi over 4 over 2 plus c equals 0. Sine of pi over 4 is 1 over 2. So sine squared of pi over 4 is 1/2. So 1/2 divided by 2 is 1/4, right? So this whole thing is just, so this whole thing is 1/4 plus c equals 0. So c equals negative 1/4. Okay? So we can plug that in for here, and I'll get that my velocity equals sine squared of pi over 4 over 2 minus 1/4. Okay? So basically now what I want to do is I want to figure out, okay, this is my velocity function. Here's my acceleration function. When do these have the same sign? So when are they either both increasing or both decreasing? That's the question. Okay? So, or sorry, that's when they're both positive or both negative. That's the question. Okay? So what we're going to do is we're going to graph both of these again. I love graphing, if you can't tell. It's a really good way of seeing your information in a really visual manner, right? So I'm going to graph a of t, and I'm going to graph v of t, right? And I'm just going to look, and I'm going to say, all right, in this interval between 0 and pi, when are they either both positive, so they're both above the x-axis, or they're both negative, they're both below the x-axis. And if you do that, you'll clearly see that there are two distinct sections where they're either both above or both below, right? So I can see that they're both positive on the interval from pi over 4 to pi over 2, right? Pi over 4 is about 0.785. So if you find the actual number, you'll get 0.785. And then pi over 2. And then you'll see they're also both negative between 3 pi over 4 and pi. Okay? So these are the two intervals where they're both the same sign, and therefore this is the times where they're both speeding up. So between pi over 4 and pi over 2, and 3 pi over 4 and pi. And that matches up with option choice E. 19. If f has inflection points at x equals negative root 2 over 2 and positive root 2 over 2, which of the following functions could be f of x? Okay, so there are two ways of going about this, alright? The first way, in the slightly more faster way in my opinion, is you're going to take the derivative function in your calculator. So if you have a ti, right, you'll have the derivative, and then you have like the thing, you have like x equals whatever, right? And then in here you're going to put another derivative. So then you'll have like derivative section. You'll have the derivative of the derivative of something, right? And then you'll have at x equals something, and then you'll have another one, x equals something, right? And the reason we're going to do this is because we want to find inflection points, right? So to inflection points, you're saying, okay, where is my derivative, my second derivative equal to 0? Right? My second derivative is equal to 0. That's where I'm going to have my inflection points, okay? So what I'm doing here is this double derivative is taking the second derivative, so it's finding f prime of x, right? So I want to find out each of these different functions. I want to find each of their second derivatives. That might take a bit of a long time to find 5 different derivatives, right? So what I'm going to do is here, I'm just going to take this, I'm going to take the derivative of f of x, and here I'm going to put x equals x, because this is just the first derivative, and then at the second, I'm going to plug in one of these 2 points, whichever one I want. So for example, the first one, I'll choose square root of 2 over 2, okay? So if you put, so you'll put here x to the fourth plus 2x into here, and then you'll put x to the fourth minus x squared plus 2x into here, and down, 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 until you find a point where this guy is equal to 0, right? That's going to be where the second derivative is equal to 0, right? This is the first derivative, and this outside part is the second derivative at square root of 2 over 2, and if that's equal to 0, then we have the second derivative equal to 0 as well. If you don't want to use the calculator this heavily, if you're not comfortable with doing that, well, it's not the AP exam yet, so you have time to get comfortable, at least when I'm recording this. But if it's the day before the exam, or you just don't want to risk it, you can figure it out manually, okay? So we'll just have to take the second derivatives by hand. So for this first one, the first derivative is going to be 4x cubed plus 2, and the second derivative is going to be 12x squared. And you notice that this is the only time where this is equal to 0 is x equals 0, right? So that's not going to work. Option A is out. Option B, x to the fourth minus x squared plus 2x. We take the derivative, we get 4x cubed minus 2x plus 2. Take the next derivative, we get 12x squared minus 2. And if we set this equal to 0, you're going to get that x is equal to plus or minus 1 over square root of 6, and that's not equal to this. So it's not, the second derivative is not equal to 0 at these points. So option B is out. Let's go to option C. If we take the first derivative of this guy, we'll get 4x cubed minus 4x plus 2. If we take the second derivative, we'll get 12x squared minus 4. You set this equal to 0, and you'll get that x is equal to plus or minus 1 over square root of 3. And again, that's not equal to any of these, so we cross it out, keep moving down the list. Take the first derivative of this, and we'll get 4x cubed minus 6x plus 2. Take the second derivative, 12x squared minus 6, and you set this equal to 0, and you get x is equal to plus or minus 1 over square root of 2. And now remember, 1 over square root of 2, this is actually equal to the square root of 2 over 2, right? 1 over square root of 2, square root of 2 over 2, these are the same thing. So actually, this is actually equal to plus or minus square root of 2 over 2, which is the 2 points that we have here. So this is the function that gives us the second derivative equal to 0 at these 2 points. So this is equal to f of x. 20. What is the absolute maximum of f of x if the second derivative, if the first derivative is equal to sine of x and f of 0 equals 0? Okay, so first thing we want to do is we want to find f of x, right? So I have dy dx here, and I can say that dy equals sine of x dx. Integrate, and I get y equals integral sine of x, which is negative cosine of x, plus c. My initial condition is f of 0 equals 0, so we'll say 0 equals negative cosine of 0 plus c. Cosine of 0 is equal to 1. This is going to be 0 equals negative 1 plus c, so c equals 1. So in my original function, I'm going to get y equals negative cosine of x plus 1. Okay? Now the question is, what is the absolute maximum of this function? Well, I know that the absolute maximum of negative cosine of x, that's going to equal 1, right? For example, when x equals pi, cosine of pi is equal to negative 1, so negative cosine of pi is equal to 1. That's as high as we're going to get. And so if this maximum is 1, then the maximum of y is going to be 1 plus 1, which is 2. So we're going to go with E there as our best answer. 21. When approximating the value of the integral from 0 to 5 of f of x dx using Riemann sums, it is found that both a left-hand sum and a trapezoidal sum provide an underestimate. Which of the following phrases could be used to describe the function f on the interval from 0 to 5? Concave up and increasing, concave down and increasing, concave up and decreasing, concave down and decreasing, and the answer cannot be determined. I don't know about you guys, but I feel like this answer cannot be determined. I've never seen that actually be the answer to anything. I just put that because I didn't want to give away which one it more likely would be. So it's kind of like a throwaway answer to me, but I don't know if it's actually a throwaway answer. I don't know if it's actually ever been the answer. So yeah, just a quick note about that. Anyways, so we know that both a left-hand sum and a trapezoidal sum provide an underestimate. So for a left-hand sum, you can easily visually see that when the left-hand sum provides an underestimate, your function is increasing, right? If this is your axis, and then here's your function, this is an increasing function, and my left-hand sum is leaving out this little, let's do a different color. It's leaving out these, let's do orange. It's leaving out these little, it's leaving out these little triangles here. So since this is a increasing function, the left-hand sum is an underestimate. So if I have my left-hand sum being an underestimate, what that means is that f of x is increasing. And it's a bit harder for a trapezoidal sum to visually see it, but you should have learned in your class at least that if a trapezoidal sum is an underestimate, then the function is concave down. So the left-hand sum is an underestimate, so the function is increasing, and the trapezoidal sum is an underestimate, so the function is concave down. So that means the function is increasing and concave down and increasing. We're going to go with B there as our answer. Finally, a table question. For all x in the closed interval from 0 to 4, get everything, okay, there we go. For all x in the closed interval from 0 to 4, f of t is greater than 0, while f prime of t is less than 0. Which of the following could be a table of values for g of x, which is the integral from 0 to x of f of t dt? So basically, g of x is telling us like the area under f of t. So the best way to do this, in my opinion, is to draw a sketch of f of t that meets these conditions, right? So f of t is greater than 0, so that means it's above the x-axis, right? And the second derivative is less than 0, which means it's decreasing. So I'm going to draw a function like this, right? So this is 4, the closed interval from 0 to 4. So as you can see here, my function is above the axis, so it's greater than 0, f of t is greater than 0, but it's sloping down, so the derivative is less than 0, right? And if I were to say, okay, this is 2, this is 3, this is 1, notice what's happening is I'm still gaining area, but the area that I'm gaining is less as I keep going up, 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 up. So the area that I gain from 1, so like the integral from 0 to 1, this is f of t, by the way. Right, the integral from 0 to 1 of f of t dt is going to be greater than the integral from 1 to 2 of f of t dt, which is going to be greater than the integral from 2 to 3 of f of t dt, f of t dt, which is going to be greater than the integral from 3 to 4, right? So every 1 I go up, this area is greater than this area, and it's greater than this area, and so on, so on, so on, okay? So I'm going to see which of these tables meets that condition. First of all, I can eliminate this right off the bat because it has negative numbers in here, right? And that's not going to fly. Okay? Next up, I can eliminate C because I see here, alright, look, I'm increasing by 3, so that means this area is 3. And then from 1 to 2, it went up by 4. So 3, this is 4. And here it's going up by, what is that, 8? And then here it's going up by 8. I think that addition is right. So you can see it's going up by more and more and more. So this is obviously not right because we want the area to be increasing, but increasing by less. Okay, and so now we're down to A, B, and D. If we look at B, notice that here it goes up by 5, here it goes up by 3, and we're thinking, oh, this is good, must be right? But if we look from 8 to 11, notice that again only goes up by 3. But we said that the integral from 1 to 2 should be greater than the integral from 2 to 3. But these guys are equal. This one isn't greater. So I can eliminate B as well. Now we're down to A and D. They both might seem to initially fit the conditions, right? It goes up by 4, then by 2, then by 1.5, then by 0.5. And this guy goes up by 6, then by 4, and then by 2, and then by 1. So, okay, how do I know which one is right? Well, the key here is in looking at g of 0, okay? G of 0 is the integral from 0 to 0 of f of t dt. And the integral from one number to that same number is always equal to 0. So g of 0 equals 0. Here it says g of 0 equals 1, so that's out. And the only answer that we have left is option D. Okay? And that is the end of section 1, part B. So that should have taken you about 24... Is it 24 or did I say 27? What did I say? I don't remember. 24 minutes, right? Okay. So hopefully that this video was helpful whenever some calculator multiple choice questions. We didn't use the calculator in all of them, but you're not going to on the actual test. It's only going to be some questions that require a calculator. Okay? I hope you found this review helpful. Hope it helped you practice your problems, get ready for the AP exam, get ready for whatever calculus you have, and yeah, that's it. I will see you in the next videos where we're going to be going over the free response questions. Okay? And yeah, with that, like and subscribe, and I'll see you next time. Okay? Goodbye.